All right, today we're in section 5.5, graphs of proportional relationships. So we are finally working on our graph paper where we've already identified are the ratios proportional. That's what we did yesterday and what we were tested over yesterday on our test. So now we're looking specifically at a graph to determine if values are proportional. Well, in order to be able to do that, we have to have an understanding of the coordinate plane. And that's what you guys are doing on your papers right now. You're setting up a graph that looks like this on your graph paper, where your axis that goes up and down, that straight line that you drew up and down, is the y-axis. So make sure you label it the y-axis. Y is very important. These are my y values in the ordered pair. The horizontal axis is my x-axis. All right, again, that's really important. So when I look at my ordered pair template, and you can write this over on your notes, not on your graph paper, the ordered pair template, and this is how it's going to be in any ordered pair that I look at, whether it's in an equation or in this case in a table, and I'm trying to see if values are proportionate. I'm looking at an ordered pair, and the first value is x, and the second value is y. All right, and that'll make a little bit more sense in a minute. Okay, this is my ordered pair template. All right, now on the numbering of your graphs, every block will be 1. Okay, so that's why the blocks, and that's why we're using graph paper. Every block should count as 1 unit. Now this is different from the way that we set it up in 6 Hour. I actually had a totally different graph that skipped lines, but skipping, like skip 1 and then do 2, skip 1, 4, skip 1, 6, totally messed everybody up because they weren't skipping the blocks, okay? So let's just label every single one, okay? So at the very middle where the x and y axis intersect, this point is called the origin. You need to write that down on your notes. Okay, so point 0, 0, all right, which is where x and y intersect, is called the origin. All right, it's called the origin. All right, and you're going to hear us talk a lot about the origin in today's lesson, because in order to determine if values are proportional, the line has to pass through that point, okay? Well, in order to be able to tell that, though, we need to understand how these points are even plotted on the graph. So that's what this slide is for. All right, so on your notes, I want you to write down these 5 ordered pairs, A, B, C, and D, on your notes, not on your graph paper, but on your notes. All right, and I like to view ordered pairs as kind of like the map to tell me where to go, or the directions to tell me where to go on the map. The coordinate plane is my map. The ordered pairs are my directions that tell me where to go. So now that we have our graphs numbered, okay, our ordered pairs tell us where the points go on the graph. And in specific order, the first number in my ordered pair is my x value. So if it's negative, I'm going to go left on x. If it's positive, I'm going to go right on x. If it's a positive y, I'm going to go up. And if it's a negative y, I'm going to go down. So it all depends on the value and the sign. So on point A, I'm going negative 5, 6. So I always start at my origin, right there in the middle. And because my x value is negative 5, that means I go left over here to negative 5. But that's not where my point goes. And don't draw the arrow on your graph. I'm just showing you. Okay? So I go left to negative 5, but then I need to go up 6 to get to my point that I need to plot. Okay? And then you're just going to label it point A. Point A. All right? So point A, again, I follow both coordinates. It was negative 5, so I went left on 5, positive 6 for y, so I went up 6.
Do we draw lines to it?
You don't. You do not draw lines to it. It's a really good question. We're just plotting the point. We're practicing following ordered pairs to plot points. All right, you have 2 problems like this on your homework tonight. So that's kind of why we're looking at this. All right, so now point B, -2, 4. So for point B, I need to go, what I go, left 2 or right 2? Left 2. So my x value is -2, so I go left 2, and then I go up 4, and I plot my point, and that's point B. All right? So my ordered pair is kind of like my directions. It's telling me where I need to plot the point on the coordinate plane. All right? Look at point C. I want you to try to figure out where point C is going to go. Now C is at +5, and then +8. +5 and +8. Okay, so since my x value is 5, am I going to go right or left now? Right. I'm going to go right 5, and then would I go up 8 or down 8? Up 8. Up 8. So now it's going to be a little bit off my graph. It's like all the way up here at the very top for point C. You might need to just draw a couple, a couple more numbers up there at the top of your Y. And that's where point C goes, 5, 8. All right, so are you kind of following along with what we're doing? Yes, if x is positive, I go right. If it's negative, I go left. If y is positive, I go up. And if it's negative, I go down. All right, what's different about point D? There's a 0 for x. So that means I don't go either way on x, and then I just go straight up to 6 or down? I go up to 6 because it's positive. All right, and then my point goes here for point D. Okay, now I want you to try point E. Right 2 or left 2? Right 2, and then up 6 or down 6? Okay, so was your point right about here? Yes. Okay, and that was point E. All right, so are we getting comfortable with plotting the points? Yes. Okay, so in today's lesson, that's a lot of what we're doing. Okay, I'm actually going to skip the terms, and we're going to go over the term and the last 2 examples tomorrow. I'm going to focus specifically on the graphs for today. Okay? You're going to have a table of values. You have 2 problems like this on your homework tonight. It says, are the quantities proportional? Well, you actually have already answered this type of question. Do the ratios form a proportion? Is kind of how it was worded on your test. But you had ratio tables. Now you're looking at the same type of a table, but you're proving that they're proportional by plotting the points on a graph. Okay, so this is going to be the second graph that you do. And let's try to get our numbering closer. So I know, and again, I just probably should have picked a different one. But make sure that your dashes are right on those blocks. So -1 should go here. Actually, this is what I'm going to do. All right, I'm going to kind of redo this a little bit. All right, -1 should go here, and then -2, -3, right on those grid lines, guys. -4, -5, and -6. Make sure they're right on those grid lines, okay? So we're going to use the table, and we're going to make ordered pairs from these values. So my first ordered pair is 1, -2. What's my second ordered pair? 2, 0. And then what? 3, 2, and 4, 4. Okay? And now I'm going to plot these 4 points on my graph. All right? So I go over 1, down 2. And you don't have to worry about labeling them A, B, C, or D. Oh, I'm sorry. I just labeled that wrong. Over 1, down 2. There we go. Okay, where does my next point go? 2, 0. All right, and go ahead and plot the last 2 points. I'll give you a minute to do that. So where's my third point? Where's my third point? 3, 2. And where's my fourth point? 4, 4. Okay. Now, these are, and we haven't quite learned this yet, but these are what we call linear equations too, just basically means that you're forming a line. Okay, you're forming a line through the points. So now let's draw the line through all of these points. And here's what we're trying to find, okay? And on your paper, okay, back over to your paper where you've written down the ordered pairs in the table, we're going to answer the question, are the quantities proportional? And our main criteria to say yes or no is, does the line pass through the origin? Does it pass through 0, 0? No. So I would say that they are not proportional. No. Because the line doesn't pass through the origin. Does not pass through origin. And I'll abbreviate through. Okay. Does not pass through the origin. All right, so my only criteria, once I plot the points and I draw my line, does the line pass through the origin? If it does, my answer is yes. If it doesn't, my answer is no, and that's my reason. I want you to do a whole new graph. It just takes up so much time. I just want to look at, and I want you to go ahead and graph these 3 ordered pairs. If you have a different color pen or pencil, maybe use a different color because you're working on the same graph. But we're going to pull out these ordered pairs, plot them on our graph, and say yes or no whether they're proportional. Remember, the question I'm asking is, does the line pass through the origin? Okay, does the line pass through the origin? If it's yes, then they're proportional. If it's no, then they're not. All right, so my 3 ordered pairs are 3, 2, 6, 4, and 9, 6. 9, 6. Okay, remember it's 6, 4, the X comes first. Okay, so that's actually, that's a good point to make too. Remember, the X value always comes first in the ordered pair. Don't write it backwards. Okay, so we're matching them up. Yes, X, Y here, but X always comes first and then Y. So let's plot these points. One of them goes off the graph. That's okay. Over 3 up 2. Over 6 up 4. And then it says over 9 up 6. So we know that we're somewhere around like this point over here. Okay, that's okay. All right, now I'm going to draw my line. Draw my line, hopefully, through these points. The arrows on the ends of the lines basically mean that the arrow continues on, that there are more solutions than just these 3 solutions. And sorry about that random line. That shouldn't be there. Okay, so now does this graph pass through the origin? Yes. So I would say yes, they're proportional. And again, my reason, because the line crosses the origin or passes through. Either way. Crosses, passes through is the same thing. Crosses. Crosses the origin. Sorry, got distracted there. All right, let's look at unit rate now. I need you to turn in your books. I couldn't get this graph on my PowerPoint. It just looked too pretty in your book. No, it's kind of goofy. Once you see it, you'll know why. We're just going to refer to our book, and that's fine. Turn in your books to page 213. So let's look at this graph. It says the graph shows the speed of a subway car. So we're thinking like New York City, that type of thing, a subway car. Find the speed in miles per minute. So one thing that we have to focus on is which unit are we finding the unit rate for? Is it miles or, per mile, or is it per minute? It says it right there. It's per what? Miles over minutes. Because I'm looking for how much per 1 minute. Okay? So how did I know I was setting up my fraction this way? I looked at the graph and I looked at what it was asking me to solve for. So guess what? If it had said minutes per mile, I would have wrote it in the other, I would have flipped it, okay? Do you see why I wrote it this way? Because whatever I'm finding the unit rate for, that unit goes on the bottom. So now I need to read my graph. I want to know how many miles per 1 minute. So I need to follow the graph over to where the value on the minutes is a 1. And now look up and trace up to see where that point is and what value in distance that matches up with. So look over on 1 minute, that's your horizontal axis. Now follow it up. How many miles is it in 1 minute? Guys, look, 1 minute, go over to 1. When you follow it up, it's 1/2.
Oh, it's 1/2.
1/2. So it's 1/2 miles per 1 minute. Now, is there another way that I could write this ratio, not in a fraction? Absolutely. Okay, I could just say 1/2 mile per minute. Okay, I could just say that. All right, but I'm reading the graph, guys. So again, whatever it asks me, it might be my vertical axis that I'm looking for, okay, how many minutes per mile? And now I'm looking on my vertical axis for the 1 value. Does that make sense? Unit rate, okay? So I did it this way because it was asking for miles per minute. All right, so you're going to have to read actually 2 on your homework. I have one more example in example 3. All right, we again are going to look at the book and we're going to read this graph. It's a robotic vacuum. Anybody have that, like the Roomba? Okay, robotic vacuum. So this graph, guys, this graph shows, depending on how long the vacuum is running, how many square feet the graph is showing us. Okay, so again, it says find the area cleaned in 10 minutes. Well, in order to find the area cleaned in 10 minutes, I need to find how much it can clean in 1 minute. All right, because my graph doesn't go out to 10 minutes. It only goes out to 3 minutes. But if I know how much it can clean in 1 minute, then I can multiply it by 10. All right, so here's how I set it up in an equation. This is how you would set it up if you were given a problem like this. Y equals, okay, I need to find my rate. Okay, my rate is how many feet per minute. So read the graph, go over to 1 minute, and follow it up to that point. How many square feet am I covering in 1 minute? Okay, so follow over to the 1 minute, and now follow it all the way up to the point, and what is it? It's 16 feet per minute. Do I know how many minutes I'm trying to gauge? 10. So I just plug in my 10, and y equals 160 square feet. I could do feet squared, square feet, either one. All right, feet squared in 10 minutes. All right, so just learning how to read a graph and find the unit rate. Whatever unit it's asking you for, that's the unit that goes in your denominator or the one that you're finding per however many, okay? So to find it in 10 minutes, I needed to know how much is covered in 1 minute. All right, and that's it for part 1. We're going to do the last 2 examples tomorrow.